Hello. Welcome to any combo lords joining me here in the present or future. And today, on our date that is often written as 32323, we are in a windy moment, but luckily not a rainy moment here in the combo classroom. It has been pretty wildly stormy. There's all these trees around dropping giant sticks all over the combo classroom, and also just knocking a lot of stuff over and going hand in hand with the water to cause a bit of chaos, but also a bit of interesting stuff. As I was cleaning up the combo classroom today, which, if you can see from a wide view, has quite a large angle going for it, we can see that as I cleaned it up and it's super muddy on the ground, there was a whole river running through here, turning it almost like a wetland. And in between the old pieces of the desk and the little lake of sorts, some wildlife did develop. So, first of all, there were some worms that were expected. I knew that worms like to hang out around here, and they're great. They'll help me decompose in that potting plant right there, or planter thing. But what I didn't expect is that as we were cleaning through old wood and cardboard and stuff in the zone that had been wetlandish a little while ago before the water drained, there was a little worm-like thing that seemed to have legs. And in fact, as we looked close, it did have legs. This little worm-like thing was not a worm. It had whole sets of legs, and it was a very long, thin amphibian of sorts. At first we thought maybe a newt. We being me and one of my main camera people, Carlo, we were working today filming stuff and cleaning up the classroom, and we found a couple of these little things that looked like newts, and upon research, I believe, were salamanders. Now, I got a cool little clip of them in a new little habitat that we made for them temporarily, and Carlo brought them home to try and build them a bigger habitat, because the water here drained, but they might be good little pets in a little tank of sorts if you kept them well fed with the right research and stuff. And I want to show you the type of creature that we ended up finding. There's these things, apparently, called slender salamanders. Now, these slender salamanders are long and thin. Their genus name means frog lizard, and they look like worms with little legs. See this thing? This is what was basically in the convo classroom. Somehow an egg of it traveled downstream when the rainwater and the floods and wind carried all this rain and stuff somewhere, and then they hatched and grew into a couple little slender salamanders, as they're apparently called. Now, I'm guessing that it's either the type called the California slender salamander, or there's another type that could have been in my region. Maybe this one also says California, as well as a few others. Another one that seemed possible was the garden slender salamander, but I think it might have been this California slender salamander. In any case, it looked a lot like this one, like a worm with legs. And now Carlo's going to try and make a little habitat for it, and we shall see if it works well. Now, let me pull up my chat and make sure this is working well. And yep. Thank you, everyone, for joining me here today. Just getting the chat here so I can see it while we have our computer screen as well. And in today's stream, we're not mostly going to be talking about slender salamanders, although they are quite cool. So maybe I will make a little cameo of them in the... And how do I get to the chat here? A cameo of them in the finale episode that I'm editing right now. In this finale episode, It might end up being about an hour or so, and I promise that it'll come out on the main Combo Class channel sometime in March, but it'll probably be quite near the end of March, because it's going to take a little bit of editing and such. Now, as for if this bites, a comment asked, I don't think so. It didn't bite us. Carlo, when he held them, was wearing gloves, so I only held them in a little jar that we made them with some dirt and water and moss and stuff. So they're amphibians, so it's hard to know exactly what they want. Amphibians are harder to care for. They like a mix of water and land in different varieties depending on the amphibian. But maybe Carlo will be able to raise these and we'll get them another cameo. They'll probably at least get one cameo in the finale. Due to all the editing, because I have like 5 hours of footage of that I'm starting to cut down. I'm just almost done filming, and the editing will definitely be a busy week, but I do want to drop it in March. So it'll probably be coming near the end of this March, so I know that I can get it right. Then, although I was hoping maybe that I would have grade -2 ready on April Fool's Day, I think that was overly optimistic, and I'll have some sort of other special on this channel then, and the official grade -2 launch some point in the first week or so of April, pretty early in there. All of it will be coming soon because I'm getting all the components together, such as having to have possibly fresher desk or lab coat or haircut, and other surprises that you may have to see. And as I mentioned in the description, because I'm almost done filming it, this is probably the last stream, or maybe second last, where you're going to see my hair this wacky, and where we might even get to see the classroom in this state of semi-modular reset. This is the classroom when we had enough room to camp in it, and then it flooded, but a lot of space with all the clocks over there. Room for new desks and chairs to sink into the mud. And there are, like I said, other fun surprises, so stay tuned for what grade -2 will have in store. It will definitely, in this weekend at some point, probably Saturday, allow me to finish my conceptual bit of my half haircut in the episode and finish cutting this off. I'm just going to cut this off myself with scissors, do my best guess like I did on this side, and then get a friend to fix it later. As for this, I can buzz it off with a thing, but that'll actually be a little more handy because I keep forgetting I look like this, and the beard makes me look kind of crazy. And so when I'll be walking around town or something and I forget I look like this, I suddenly realize, like, whoa, everyone probably thinks I'm the type of guy they don't want to chat with on the street. So, as for today's themes, we're not mostly going to be talking about slender salamanders. We're mostly going to be talking about some random things with numbers composed of 2's and 3's, such as today's date. So, in my Thursday streams, one thing I'll do at the end of it will be presenting a new puzzle of the week that we do on the Combo Class Discord and shouting out some winners of the last puzzle. And as I was prepping that with the Magic Fellow, who helps me moderate the Discord and do those puzzles, I noticed, and he noticed, that the date looks palindromic, 32323. Now, I know that many places don't write the date in that format. They would write it 23-3-23 because they're putting the smallest size of thing, day, then month, then year. However, there's pros and cons to each system. I actually like that system more, but I'm rolling with the system that I'm stuck in. And here, they name stuff like Pi Day after the 3rd month and the 14th day. Not the other way. Well, the other way around wouldn't work because there's not 14 months. But we're rolling with this date being written 3-23-23. And as I was looking at that date, I realized that is a super primey date. It's full of primes. Now, how exactly is that the case? Well, first of all of the individual components are a prime number. You got 3 as a prime, 23 and another 23. Those are each prime. In fact, 23 has some interesting traits we'll look at in a moment. As far as primes, you could say it's interesting as far as 23 is the first prime that doesn't have another prime within 2 of it. And so all the other, like 2 is next to 3, and all of the other ones up to that point have a twin prime, a prime that's 2 away from them. 23 doesn't. 21 was a Threeven, 25 was a multiple of 5, no twin primes in that mix. So 23 is a little bit more isolated than the other primes of that small range. And it's made up of primes in our base. Its digits are 2 and 3, primes. However, the fact that the digits are 2's and 3's is a little bit arbitrary based on our base, because as we could see, like, let's go to a base converter tool. If we wanted to see what the number 23 of a thing, so 23 of a thing, looks like in another base, well, base 6 would write this as, they're putting it at the top. I'll clear it so these are the ones from the stream. 23 would write it as 3-5. Base 12 would write this, 23 of a thing, as 1, and then whatever digit they use to mean 11 of a thing. And that's because this place is the base number and that place is the ones place. Similar to our base. Technically the ones place is the base to the 0th powers place. So it is still related to the base, but we got bases and then ones. So a little arbitrary that it's made up of 2's and 3's. It just happens to be 2 10's plus a 3. And in fact, if we're looking at numbers that contain 2's or 3's, well, one 3 related thing we mentioned was Threevenness, and 2's seem similar to evenness to a degree, the numbers themselves. And this number being prime is neither even nor Threeven. And it would be Threeven, the digit string 2, 3, would be Threeven in any base that was Threeven. Because we have 3 1's is a Threeven amount, so we need this to also be a Threeven amount to add up to it. So this will be a Threeven amount for any integer in a Threeven base. So 2, 3 in base 3, base 6, base 9, base 12, etc. would be a Threeven number, but not in our base. Now, leave a comment if you have any thoughts on if this would ever be an even number. Now, with 2 and 3 happening to be this in our base, let's notice one fun other one I noticed is that in the string 3, 2, 3, 2, 3, a fun thing I noticed when fiddling with bases is 3, 2, 3 in base 6, the string that they write 3, 2, 3 refers to the number we know as 1, 2, 3. 3, 2, 3 in base 6 translates to 1, 2, 3 in our base. That's pretty neat. They both end in that 23. Now, what about other ones? 3, 2, 3, 2, 3. That amount of a thing. I think that might have had 1 or 2 neat looking ones. But these are just fun examples of how many different ways it can look. We're going to go back to the number itself in a moment. And there's a bunch of fun ones you can find that look interesting in other bases. These ones are pretty random. So what about in our base while we're stuck here? 3, 2, 3, 2, 3 as a whole chunk. If we put it all together as one number, that whole date. Well, it turns out 3, 2, 3, 2, 3 is not only prime, but it's part of a twin prime, which aren't quite as common up at that size. So let's look at a few types of number that this lands on the merger of. We have our twin primes. Here's a list. Well, one moment. Here's our twin primes. And if we scroll all the way down at the bottom, if you're listing both of each twin prime, it's almost the 1000th. 3, 2, 3, 2, 3. You can't even see that part of the screen because I'm blocking that part of the screen, I think. So 3, 2, 3, 2, 3. And 3, 2, 3, 2, 1 make up a twin prime pair. And so the whole thing is a twin is a prime as well as all of these components of it. It also has the trait where 3, 2, 3, 2, 3 goes back and forth, actually is named an undulating number. Numbers that go back and forth, AB, 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 in terms of the digit. And you could say in a certain base, they're right here just defining the ones within base 10. But you could do it in a different base as well. And you can get trivial ones as well. You could theoretically include one-digit numbers or numbers that just have one digit than another. But they're listing the non-trivial ones here where we actually see some undulation, with one of the numbers happening at least twice. And here we get some reminiscent ones of what's coming later, 3, 2, 3. And if we look down at undulating primes, we notice something interesting. None of them have 4 digits. You see that? None have 4 digits, or 6 digits, or 8 digits. And that's because there's a divisibility trick with 11, where if you take the numbers in the odd places and the numbers in the even places of a number, and you find the difference, or, no wait, that relates to the palindromic primes. So, let's see the gap here. Here's our sequence. And these are good books, by the way. Clifford Pickover. I've read these books. I recommend these. They're good. This is actually where I first read about the undulating numbers. Not here on the OEIS, although I love this site, but in these Clifford Pickover books. Now, we can see here that these undulators are palindromic as well. And due to certain divisibility tricks, you can't have 4-digit ones. That's somewhat similar to what's in my palindromic numbers episode on the Combo Class channel. But we can see again, we don't have 6-digit ones either. But we do get ones like this mega monstrosity. And look at this. It's an undulating prime. This mega 3231. 3232323233. As well as our friend, today's date down here. The second smallest undulating prime larger than 1,000. In our base, of course. And 3's and 2's do work to make some primes, but if you think about stringing a bunch of 3's and 2's together to try and get a prime, you gotta play certain ways. You can't end in a 2, otherwise it's even. You can't have the digits add up to a multiple of 3, because then it's Threeven. And so you can't have only digit 3's, or it would be Threeven, unless it's 3 itself. And they are including some trivial ones here. Some would argue the list starts here. And with the larger than 1-digit ones, you can't have just the digit 3 or it would be Threeven, but the amount of 2's you have can't be a Threeven number of 2's, or it's still Threeven, with all the 3's and then a Threeven number of 2's. So you need some 2's in the mix if you want a number composed of just 3's and 2's that's prime and more than 1 digit. You need some 2's in the mix at least, and some 3's in the mix because you need to end in a 3. But the amount of 2's you have has to be a throd, meaning like not Threeven, number of 2's. You need like 1, 2, 4, 5, 7. You can't have a multiple of 3 amount of 2's in the mix. You can't end in a 2, but you need some 2's. And you could even say the needing some 2's is saying that it needs to be a throd amount of 2's, because 0's Threeven. So we can't have a Threeven amount of 2's, including 0 of them. So where's the list of which numbers composed of just 2's and 3's are primes? Well, the OEIS has that, because they have all sorts of great sequences like that. And I just found this by searching 2, 3, 23. And I'm like, okay, they got a sequence with these. Primes that contain digits 2 and 3 only. So Here we can see you do get a bunch of them, but they follow the rules I mentioned. None of them end in 2's. They all have a throd amount of 2's. So either like 1, 2, 4, 5, 7, 8, or some throd amount of 2's. And they all have some amount of 3's, or at least one 3 at the end. This is one that only has a single 3 at the end. And these are fun. I like these. Here's the one that's today's date lookalike. And if you write your date the other way, where you write the day first, 23, then 3, you'll get your prime in 10 years. 23, 3, 33. Also, in 10 years, if we write our date the way with the month first on March 22nd, that will be that. And oh my God, something I just realized is that looking at the date, I completely forgot this too. I've been going so fast through March that I forgot last March was when I got the first hip surgery I had to get, of a major intense surgery that I had to put ceramic to replace some broken bone stuff in me and titanium and stuff. Then I had to get in the other hip in July. But I just realized that that was almost exactly a year ago, because I think it was on the 24th of March I got the surgery. Not positive. It might have been the July one, was something like that, but it was late March. I think maybe the 24th, which would mean 1 year ago I was fasting for the surgery and getting panic attacks because it's a crazy process. I mildly described this in the finale episode, but just to mention one other brief thing about it. It's crazy. You get sat down in the way I had to get my surgery, sat down in a hospital bed, but not the one you're going to get operated in, jab you in the back with something that numbs the whole lower half of your body, then put a mask on you that knocks you out a bit with some stuff, and then when you're like half knocked out, they wheel you into the operating room. And then only when they're like ready to go do they fully knock you out. And one time they had me mostly knocked out when they wheeled me in there. The second time they like barely turned the stuff on until I was in the operating room ready to go. So I'm just like sitting there all anxious, like, guys, could you turn on that knocky outy stuff? And I do remember that time, the second time, one of the people asked, so, like, trying to make small talk and distract me. So, what do you do, like, day to day, like, for your job or whatever? And I was like, I'm a music teacher, but I make this show called Combo Class. I don't even know if I said the music teacher part. I remember I told him, I make this thing called Combo Class, and then they knocked me out. But the scary part is that right before, they're, like, scary in a kind of comical way. As I'm in the operating room, and they have, like, all these tools around me ready to go, looking at the wall, they have a big either computer or TV type screen on the wall, and it has a picture of the x-ray of the broken part of my leg, and then looking like the two things it looked like immediately are either like a PowerPoint you would make in school, you know, PowerPoint presentation, or like a YouTube thumbnail where they put the red circle, you know, where a bunch of YouTube thumbnails to try and get your attention are like, there's a red circle around something. Well, they had that. It's like on the wall, the broken part of my leg with this red circle around it, looking like a YouTube thumbnail. And it's like, oh, guys, I hope you didn't need the red circle to know that that's the part you're operating on, right? In any case, we got through that. And I'm going to discuss that more in the finale episode. There is it's somewhat about that, because we take a field trip in the finale, and the field trip is somewhat meaningful because it represents my inability to take field trips, either for the class, what I call the field trips where we go random places here, or in my own loving of nature, of hiking and camping. I was unable to. And so going back to places in nature that I used to go all the time, that I haven't been in a while, is awesome. And I also went camping in the finale, as some of you saw in a live stream hint. Not camping full on, like we will do sometime, like I love to do, but camping here in the combo classroom in a tent. So semi-camping. Tenting out in the combo classroom. There'll be a scene of that as well. and some fun other stuff. So, thank you to everyone leaving the comments. Remember not to leave too many comments if I haven't gotten to your old ones. Otherwise, it'll be too much for me to get to any of them. But I do like all of the thoughts. And thank you all. So, I will answer one question from this fellow leaving a lot of comments, but make sure not to leave too many thoughts so there's room if other people want to jump in. But I will answer one or two of these when you're asking philosophical thoughts about what are digits or hieroglyphs or things. Well, you could say that when I talk about a base, it's sort of a subset of what's called a numeral system. A numeral system is a way of writing down different numbers. And you could call Roman numerals a numeral system, even though they didn't have a zero or the same way that bases that we know work. And when you hear base, people usually mean what I started calling a basic base, because I thought it's good to clarify what we're talking about without having to give the full definition every time, which by basic base, I mean a base where you create numbers based on spots that are powers of the base number, starting from the 0th power, going that way, using digits for the numbers between 0 through 1 less than the base number, and the base number is an integer, 2 or greater, and all the rules that base 10 follows, but with a different number. That I started calling a basic base, so that we can be clear here in class and know that I'm talking about that type when I'm saying this rule applies to all basic bases or something like that. Because then we can have fun and be like, what if we made base 2i? What if we did this? And try other systems. Most of the systems, if not all, that we have tried so far in combo class, all the ones we've at least done full episodes about, are what's called a positional numeral base, where each position you use the same digits in different spots, but depending on the spot it's in, it's worth a different size or amount of it. So the way that our positional ones that I'm calling basic bases work are its powers of the number. Like 10 to the 0th power is 1. We just think of it as ones place. 10 to the 1th power is 10, then 100, then 1,000. So we have talked about a lot of positional numeral bases, and we've done a lot of extensions in this grade. Like, what if we made them irrational numbers, fractional numbers, imaginary numbers, complex numbers of different types? And so those extensions are awesome and will continue. For example, one episode we'll look at in grade -2 is the base called balanced ternary, where it's similar to base 3, but your digits are 0, 1, and a character for -1. And it has some really interesting properties. It even relates to some fun little puzzles about weighing things that we'll start the episode off with. And we will do more things like that are positional numeral bases of a very similar variety to my basic bases, but a mild extension. However, maybe we will also look at other types of numeral system, of ways you could write something like hieroglyphics or whatever. And you also get towards other types of algebraic structures, because if you look at what makes up certain bases, you can compare their patterns to certain tables in other theories of abstract algebra or different fields of math. And you can sort of go a few directions from the base, where we're looking more on the languagey end, or we're looking more on the what axioms make what theorems work end. So there will be a lot of extensions, because I think it's important to think outside the box and to not get too addicted to any structure that you're used to in your society, whether it's that the first 3 letters go ABC, or that we will always count in base 10, or things like that. Don't get too addicted to. Change can be good. So, heyo to the magic fellow, by the way. And what is up to all of the folks? So, numeral systems and bases will have a lot more fun. A few examples of ones we'll go into next time. One will be about like I said, balanced ternary. Others will be back to larger tables of bases to look at full patterns in them. And one pattern that we're going to look at, for example, is what are if you look at the table of representations in this base for this amount of a thing, what's the representation, or either axis could be either, then what interesting patterns do you get if you make a massive version of that and color in all of the appearances of a certain string? Similarly, if we take a certain string we're used to meaning something, what are the first time a given string appears? Or what are strings that only appear in certain ranges and it actually looks graphic, like we're going to see a graph-like shape when we zoom out? And sort of along those lines is like, we think of numbers like 33 as being super 3-like, but is 33 the real double 3 number, or are there other more double 3-y numbers? So, a lot of more stuff to explore in those realms. Of course, people have also recommended that I talk about something that will come in either grade -2 or -3. To be safe, I should study this topic a little more before I make an episode about it, because while I know a bit about the topic I'm about to mention, I like to, be pretty comfortable with having encountered something in many ways and played around with it for a while before I make an episode about it. So this may be a year out that I actually make an episode about this topic. But something that's very interesting people have requested is something called the p-adic value, or p-adic number system, essentially. And it's a metric or a way of looking at numbers that's completely different than how we're used to looking at numbers. So it has traits where if two numbers are divisible by a really large power of 2, then maybe under some senses in some land they have more in common than a number that happens to look the same because it's one away from it on the number line. So p-adic numbers are a very different whole way of looking at numbers, and it's p-adic with the letter p, which is substituted for a prime number typically. And you could talk about something like the 10-adic too, but they put the p in there for prime for a reason. And when you really get down to the extra fundamental laws and theorems, we're going to be looking at things like the 2-adic metric and things, among other numbers there. So those are fun. Those will be in an episode someday, and they're somewhat similar to bases in some ways. Now, as far as all of our 2's and 3's, these are some pretty good prime numbers. And we also have all the primes within it, because within 32323, we had a bunch of other smaller strings. However, some weren't prime. 323 was not prime, and we can actually see here under the Wikipedia article for 300, they list some other numbers in that range, and 323 happens to be 17 times 19. It's interestingly the product of a twin prime pair. So it's 323 is not a twin prime like 32323, but it's the product of a twin prime pair. And funny enough also, when I looked at this, I noticed 322 is 2 times 7 times 23. 23 keeps coming back. So if you take 323, has some twin primary traits, subtract 1 from it, it has 2, 3 in its factors. We're getting a lot of 2, 3's in this date and this live stream. And thank you to everyone else joining, and whether people have to come or go at what time, great to have you all. And as a reminder for anyone who does have to go, this week I'll be a little more busy in terms of not dropping as many new shorts or bonus lessons on this channel while I work on that crazy finale episode. and the grade -2 intro. But I will be dropping the test answers in 2 more videos or so of going through the answers to the final exam I made. So for anyone who did or didn't do that, if you did it, you can, if you're one of the people who actually tried all the questions on the test, then you might want to just skim through those videos and on the third one, look at the text version of the answers. But if you didn't do the test and you don't think you're going to, it's worth watching those videos because then I'll sort of solve them in front of you and show some problem-solving tips. So one of those is out so far. Now, the finale will be coming out very close to the end of March in about a week, but it will be almost an hour and not maybe or over an hour. I'm not sure. I'm not done editing it. And it'll be at least half an hour, if not an hour. And not like my streams, it'll be a pretty faster paced to a degree hour because there's a lot of stuff I need to fit in there. We got a lot of fun scenes. A lot more squirrels too, in addition to those salamanders, and some clips with my cats and so on. And of course there's fire, and of course clocks break, and yeah, all that stuff too. Not as much number stuff in the finale because it's wrapping up our modular reset, but I will remind us that the clocks are an important theme of that, of going back to a sort of reset. You're on a different day, but you're showing some of the same numbers. But back here, if you can see that at all in the mini screen, it says 100. It doesn't say 100 if you mean 100 of a thing. It says how many episodes are going to be on the main combo class channel in grade -1. Because this finale is the 36th, but 36, if we ever switch to counting in base 6, which would be better, will look like 100. 36 is a magnificent number, by the way. It's a square number, a triangular number, a square of a triangular number, a lot of types of number. And I read somewhere online, without being able to locate the proof, that 6 is the only triangular number whose square is triangular number, or equivalently that 36 is the only triangular number whose square root is a triangular number. And I couldn't find the fact of that. I dug long and hard online, and finally I found something mentioning it, and they said, it was a post from someone saying, oh, I couldn't find the details about the fact. And I'm like, no, they were in the same boat as me. But then it said, but I found it finally in this book. And they mentioned this old textbook that they said the proof was in. And I couldn't find the text of the textbook online. It costs like $1 million. I'm gonna have to go to a library or something to find that textbook because I really want to quote that fact in an episode. I love the number 6, and I really want to confidently say that it's the only triangular number whose square is also a triangular number, but I wasn't able to find a full confirmation through like a proof or a super legit source claiming it. And so I need to find that book in a library or something. If anybody locates a proof or any knowledge as to whether it's still an open question of whether 6 and 36 have that relationship of being the only triangular, square and square root, please let me know, because I'm practically stalling a whole episode about the number 6 because I want to put that fact in it, but I'm not going to put it in until I'm sure about it. So that's a funny little tale about me and 36. All right. And yeah, to whoever's leaving a bunch of chats, you are going to be paused if you leave too much. I want it to be a space where a lot of people can chat. So if you leave more than 50 chat comments within the same hour, you're probably going to get paused or whatever. Someone's wondering base 12 or base 60. And base 60 was used by some cultures, sometimes in a way as a mix of base 5 and base 12, where you can count 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 little joints there. We got 12 little joints there. People are so addicted to, oh, we got 10 fingers. Well, come on, you don't have to count the whole finger. There are other things you could have counted, such as these joints, which, depending how many fingers you count, will be a Threeven amount of joints. If you're not including the thumb, which arguably is much different, it's the trait that makes humans so evolved, is our opposable thumb. Back in evolution, the opposable thumb was incredibly crucial for us to start making tools, make fire, cook food, have more energy from that, build stuff. So be on the lookout if you ever see any animals developing opposable thumbs. That's when we gotta watch out. However, I'm saying let them take over. Humans are probably worse for the planet than the other opposable thumbed fellas. And base 60 is cool, but it kind of has too many digits. So they would write these characters that were sort of combos. Now, if you just have 60 different digits, a symbol for each thing between 0 and 59, that sounds kind of intense. Well, come on, imagine being a kindergarten teacher and being like, no, you wrote down the symbol for 47. This is the symbol for 37 we want. And each of those are one digit each of a symbol. That'll get pretty complicated. So 60 is kind of above the threshold that works well for a human, and arguably binary, that is the simplest functional base of the same type that the other bases are, the basic bases I called them. Binary arguably is too small of a base for humans, debatably, because you would need a lot more digits to convey certain things. In our life, we may encounter like a dozen of a thing and not want to have to use that many digits to talk about a dozen. So I personally have found the best midpoint between it takes a little longer to write your digits when you have less of them, but you have less of them, which is neater. The good midpoint for me is base 6. Base 12 is not far behind. Base 12 has more supporters around the world. And I think it's just because people, for some reason, have an easier time imagining adding symbols than subtracting them. I don't know why. Or they really don't like the idea of some numbers taking one more digit to write. But it would be so much neater. The times tables are better in base 6 than base 10. The fractions turned to decimals, or then turned into hexamals or seximals, you'd call them, which... the things after the point, I still often call them decimals, even though deci in the name sort of implies base 10. And that's neater, turning fractions into other forms. A lot of patterns are neater. 6 is the product of the first two primes and is right tucked between the next two primes. And we've noticed in our base, you may have seen the number 9 in our base has cool divisibility tricks, makes it easier to know when stuff's divisible by 9. The number 11 is a lot easier to spot multiples of. Well, that would be 5 and 7 in base 6. So we'd have an easier time working with the primes 2, 3, and even 5 and 7. So base 6, super great, super neat, super lovely. We'll discuss it more in the future. If you want to see patterns that are good for base 6, any of the times I look at the mod 6 table here, which I've done multiple times, like in a video here and a video on the main channel in different forms, the mod 6 tables come up. That is basically the last digits that numbers would have in the base, and you can see that the multiplication patterns are super chill. So I like base 6 the most. Base 12 is not far behind, but I keep looking into it and not finding pretty much anything better about base 12, apart from the fact that a few numbers needed one less digit to write. Like it takes a little less to write some numbers, but you need these 12 digits that have sloppier patterns with things like fifths and sevenths. So base 12 is not that good at processing 5s and 7s. It's good at processing 2s and 3s like base 6 was. Better at processing 4s than base 6, but worse at processing 5s and 7s. So not really worth the trade-off. So someone's mentioning base 8 as well. Base 8 would be good for a computer-like one, probably. And let's see. Yeah, and base 8 I don't think would be quite ideal for us because it's so good at handling all types of evenness, but it's not good at handling threevenness or multiples of 5. So a good base would be good at digesting the most frequently encountered numbers. And even if you don't encounter 2's and 3's, they're what makes up multiplicatively more numbers than other things. They're more Threeven numbers than multiples of 5 for a given size. You know, we're not comparing the infinite sets, but for a given size, if we're using that term called natural density that I mentioned, where we scan bigger and bigger sectors of whole number between 1 and some, bigger and bigger size, and see if there's a fraction approached as to what amount of them had some trait. And for example, square numbers shrink towards 0. I showed in that's related to that test episode or video on this channel. The test answer, but it's not an answer to it. It was a bonus thing at the end of that video. And we can note that, the natural density of multiples of 5 is 1/5, of multiples of 3 is 1/3. For any size of number line that's finite, there are more evens and threevens than the others. And numbers often have their multiplicative structure come up. And so it's better for a base to be able to handle 2's and 3's than to worry about handling the later ones, unless it's already handled those. However, to handle 2, 3, and 5 fully and be really good at it, you'd need base 30 or 60, because 2 times 3 times 5 is 30. So you could use base 30 and have all those processed well. And if you want to be able to use 2, 3, 4, and 5 and be extra good at doubly even numbers too, you could use base 60. But those are kind of too many symbols. I don't think you want to learn 20 more symbols. So in combo class, we're sort of leaning toward base 6, and that is part of why I made 36 exactly episodes, including the last one that's going to come out, for grade -1 on the main combo class channel, because I imagine a future someday where humans will look back on this and say that there was 100 episodes in the grade. We'll see. In any case, thank you to the other people. Someone says I need a GoFundMe to help set up my live streams. And if you mean like running the tech and stuff that I often mess up, then I do need help with that, and I do want to hire people. And once I have more supporters on the Patreon and more views on here that YouTube shows ads on, then I'll be able to someday hire somebody to work on the live streams with me. Right now, I have a small enough budget that all the money has to go toward people who film stuff or work on things directly for a day, and I don't have enough budget to go toward hiring someone while I'm live streaming, unfortunately. I wish it would be way better, make this more like a weekly show that I could set up and prep for without worrying about the tech, but we will see when that day comes. If anyone wants to support it, you can do the Patreon for sure. And also, if you don't have any money, you can also just watch a bunch of videos and comment on them, because that always helps spread them. So, yeah, some people are mentioning the YouTuber Jan Misali. I forget if I've actually seen I don't know if I've seen the video they made about base 6, but I've seen a website they made about it that, while I didn't agree with 100% of the phrasings and the thoughts, very good for the cause of base 6. I support it, and it's awesome. So, yeah, I haven't seen that much of their work, but I'm a fan of Jan Misali from what I've seen. Definitely a thinker outside the box. Those are always good. And any fan of the base 6 world who tries to spread that will have some extra praise from me. Now, in base 6, these would all look different. If we were in base 6, as we said, we got to be careful when you're saying a translation, because we could say, does the number we know as this, what would it look like written in base 6? And the answer is that random thing. We could also say, what is the string that base 6 writes 32323 mean to us? And that version of the translation looks kind of cool. This was one of the ones I saw earlier, which is 32323. When base 6 says that, they mean the number we'd write, 4443. So that works pretty neatly. Now, that's most of what we have to look at for the primes with this trait. Here's our list one more time. However, I do want to take a look just at the number 23. Now, the number 3 should get a lot of credit too, but it will continue to get credit in many episodes. 3 will get a lot of credit in that balanced ternary episode I mentioned, whenever my Threeven episodes come up, and all sorts of stuff. In the book I'm working on about Threevens. 3's going to get a lot of credit, so we will continue to, be diving down that rabbit hole. But 23, I'm not sure when that one will come back, so let's take a moment to see what Wikipedia has lined up for their mathematical facts about the number 23. Now, we are going base independent for many of these traits. Some of them may rely on how it looks, but most of them it's not going to matter that it says 2-3. It's 23 of a thing. An example of a base independent trait was the one I already mentioned, which was it is further from other primes by some metrics than any earlier prime. 2 is 1 away from 3, and after that point, all of them have a prime that's 2 away from them, except 23 and spots onward. So 23 is a little bit lonelier than the other primes in terms of primeness, but it gets to hang out near its squares and stuff like that. And seeing what Wikipedia has about 23, while we have it twice in today's date, and let's also give a shout out just to palindromic numbers. I love these fellas. Make sure at some point you've seen the episode on the main combo class channel about palindromic numbers. That's one of my favorite ones I've made because these numbers are fun. It's not just about an R base, it's about in general bases. Like in other bases, would we have weird traits about missing digits in the undulating primes where you don't have 4-digit ones? Some things go in multiple bases. Now, here, if we look at what they have to say about 23, it's the 9th prime number, and here they note that here's how they say, the fact I said, is it's the smallest odd prime that's not a twin prime. And 2 is technically not a twin prime because that definition means you're 2 apart from it. So 2 is like a super close prime with 3. 2 and 3 are the only neighbor primes, as I call them. Primes on consecutive numbers. What's that? Now, it is a factorial prime. Okay, it's also, so it's not a twin prime, but after, okay, I'm sorry about that noise. I cannot control that. Okay. So, anyway. Oh, come on. Okay, people, don't leave because of the noise. I'm sure it's temporary. Oh, by the way, if you count in base 23, apparently its numeral system, base 23, is called trivigesimal or trivigesimal. Now, it is not a twin prime. However, it's a cousin prime. Cousin primes are 4 apart from another prime, and the one's 6 apart, since yes, the word root can either be HEX or SEX are the word roots for 6. You can have word roots from multiple cultures like Greek versus Latin, and HEX or SEX are both legitimate word roots, so the mathematicians had an excuse to call it sexy primes when they're 6 apart, which is the official name. It's also a factorial prime, meaning it is 1 less than a factorial. Meaning if you go 1 times 2 times 3 times 4 and subtract 1, you get it. And various other sorts. what other facts do they have about it down here? Here we have some traits that may emerge if we come back to the roots of unity in a future episode. All of the complex roots of the number 1. Here it says is a rare property is that the sum of the first 23 primes is a number which is divisible by 23. And according to these citations that maybe I'll look at later, that sounds fun. Oh, and what do you know? They're citing the OEIS. Classic numbers k such that k divides sum of first k primes. And yeah, you got 1, 23, 53, 853. Got them pretty spread out. And I'm not sure if there would be an infinite amount of these or not. Not sure if that's even known or not. And we have a variety of facts, and one of the ones I wanted to make sure to point out was, well, here's a fun one that also showed up earlier. This saying R23 is the third decimal rep unit prime means that the number in our base composed of 23 ones as a string, I call it a hyper 11 with 23 ones in it, is prime. And not that many of the hyper 11s in our base are prime. 11 is, then the one with 19 ones, then the one with 23 ones, and then the one with 1,031 ones, it says here. Wild. So in my Hyper 11s episode, you can see more about that. And more fun facts. The one I definitely wanted to point out is I made a short once about something called the birthday paradox. And this happens to be the important number for a year. So given that a year is 365, or you could call it 366, you'll still get this number. Days, 23 is the right constant that emerges from that, where if you have 23 or more randomly picked people, and you need like a genuine way of randomizing what birthday they have, which it's not truly random in a classroom, in a group of friends or stuff like that. If you really somehow randomly picked people so that the birthdays would have no correlation, they weren't growing up in the same neighborhood and they didn't go to the same year of school or whatever, because you never know how that will clump things. If you randomly pick people with 23 or more, it's more likely than not that at least 2 of them will have a birthday in common. Meaning not which year it was, but which day of the year. So, for example, you got 23 people in a room. If none of them have the same birthday, that's less likely than if 2 of them share a birthday. Now, that's pretty cool. It already is mind-blowing. I mean, it's really cool at first. So not to undersell that. It's wild. So that you don't think of it at first. 23. But what's even crazier to me is that when you look at a graph of it that they hopefully have here, as you go up to not that many more than 23, you get really likely that people are going to share a birthday. Looking here, if you have 50 people in a room, randomly picked, out of the 365, or you could call it 366 days, 97% chance at least 2 have a birthday in common. If you have 100 people in a room, out of the 365 days, 99.99997% chance. That's just crazy. And it's because there's so many possible combos of which people could have the birthday in common. And for each new person you add, there is a whole set of different people that they could line up with. And so, interestingly, your graph of how many people versus likelihood of at least 2 sharing goes like, yeah. So that's wild. We'll look at more statistical anomalies like that in the future, because gotta love when your gut tells you something else, and you can sort of classify it as a mini paradox almost, to that it's not paradoxical in that it's hard to explain. You can go through the math of it, but it's paradoxical in that Takes a really long time, if ever, for it to sink in as a gut feeling that 23 random people, more likely than not, share a birthday. And that with 100 people, it is almost guaranteed. So, let's see. To whoever mentioned the primes that contain the thing. Yeah, I miss which OEIS ones you're talking about, but I do love those sequences. I have tons of cool OEIS sequences saved in my notebook. And if we're ever bored on a live stream, one thing we could always do is when you go to the front of the OEIS, they actually have this feature that randomizes which one you're seeing. So, like, where is it? Webcam. So, best sequences. Reload when I say so. What's the next sequence going to be? The least possible number of intersection points of the diagonals in the interior of a convex n-gon with all diagonals drawn. And they know these terms, and it looks like they're not sure about further terms on this. Some things like this in the fields like graph theory can be really complicated to calculate higher ones. I was just reading about a new result in this thing called Ramsey theory, which I want to make a whole episode about. So I'll do a really, really quick synopsis here to not spoil much. But if you have 6 people at a party, it's guaranteed that there's 3 people who either all, if you assign a trait to each pair of people, that either they know each other before or they don't know each other. You could also assign a different on-off trait, like they're related or not related. But the common example is they're friends or they don't know, strangers. So we'll just say everyone there we're classifying as either friends or strangers with each other person as a pair based on whether they're more or less. And so with 6 people, you're guaranteed there's a set of 3 people that either all are friends or all are strangers. What about if you wanted to guarantee that with 4 people? Well, it turns out we know 4, but 5 we don't know yet. We know what range it's in, and it's the same question as asking if I make a graph and I color all the edges blue and red, etc. You can make this connection. I'll show in an episode. We know that the answer for 5 that's similar to that, called R55, the Ramsey number 55, is within this range that's not very big. It's between 43 and 48, I think, is the range. Something like that. Maybe 49, I think 43, 48, something like that is the range. But we don't know where it is in that range. And the other ones, we have ranges as well, some of which, like the 6th one, may be beyond human or any computer's capacity in our universe to ever calculate. So certain levels of those are cool unsolved questions in a field called graph theory. Now, someone's mentioning the Monty Hall problem, and that is similar feeling in that it can feel unintuitive at first. I'll for sure have a time where the Monty Hall problem comes up. I did love it as a classic one when I was younger and first getting into logical paradoxes and different things like that. It's a great one, and I will definitely present some reasons why it could feel a little more intuitive in some episodes. And someone mentioned the game Set as well. That's an interesting connection. I actually did like that game. I remember playing that randomly at some random times in my life with friends or family and stuff. And it was fun, matching patterns, that game called Set. So, who invented zero? I'm sure different people came up with it at different times. But the type of zero we use is based on something called Arabic numerals or other names related to that of various cultural places it came from. And it's funny, when people got polled once about, do you think we should teach Arabic numerals to kids in school? there was a lot of uneducated people whose gut reaction and response was, "What? Why do we need to teach an Arabic numeral to someone?" Sort of coming out of a place of like weird racism, but also ignorance to the fact that those are the numbers we teach. They're called Arabic numerals because that's where they came from. And there's other Arabic so-and-so ways to clarify exactly where they came from. So maybe I'll do a history video giving more full credit in the future. But it's funny that a lot of people's gut reaction was to reject it just because they don't know the name and didn't like the name out of some weird like xenophobic thing. So I'm not going to do our stream for too much longer on these streams, which I've been doing Mondays and Thursdays at a scheduled time, at least in March. I'm going to need to let everyone know next week if I'm going to be able to continue both those days throughout April while I'm trying to fully get some great first episodes of Grade -2. I may do one streaming day a week in April, but I will do some updates about that next week. Next week for sure, I will be doing Mondays at 10 a.m. and Thursdays at this time, 6 p.m. And sometimes this Thursday ones last extra long, like the camping one I did the other week. But this one I'm going to wrap up on the shorter end because I need to work on editing that wild finale, which only has like one more scene to film, during which this will get cut. And so say goodbye to me looking half and half. Now, I will announce some shout outs to people who got a puzzle on the Discord for a weekly puzzle thing that we do on these Thursdays, as well as announce the upcoming puzzle. Those are fun, and people who aren't on there yet, make sure to consider checking out that Discord, because I'm not like a social media or technology guy. I don't normally use apps like that much. In fact, I didn't use Discord apart from Combo Class. That's the only one I use right now. But it's fun. There's a lot of cool people chatting on there. And one of the things that's somewhat recent on there is weekly puzzle challenges. And so I'm going to pull up a little shout out to some people who got the last one. And one moment. And the last puzzle was related to a number that had to be figured out. And the first answer was by QED593. Additional information was given by Kanatan, or Kanatan, Kanatan, and it was put together by the Magic Fellow. And for more details on that last puzzle, you could go to the Discord, and there is a spot where they're written, and a spot where people put their answers with spoilers and stuff. But as for the next week's puzzle, I will announce that now here too. So whether or not you're on the Discord, you could consider trying this for your brain. And the question today is to identify a unique trait about a particular number that I should get a whiteboard to write it down. And there could be multiple answers to this. There is a solution ready of a particular unique trait of it. But if you find another unique enough trait, you can feel free to throw in other ones if you commented on the Discord or anything as well. All right. And the number is not that. That is the base 6 representation of how many episodes will be in Grade -1 on the main channel. And the number is... Oop, this is not a good pen. Uh-oh, okay. we're just going to have a pretty gray one right now. 8. I will read it as well. It's just good to have it visual, but it's going to look a little gray. Roll with me. All right. So we got 8, 5. Okay, no, I'm just going to put it in the chat. So I'm going to read the digits and then I'm going to type it in the chat. This pen's not doing good. So don't worry, we have plenty of whiteboard action in the finale. For those who didn't like the computery streams as much, a lot of those were from the rain and stuff, and you'll get all of your fix of wild nature and plants and chaos in the finale episode. Then in early April, you'll start getting your fix of the full Math Channel episodes on there as well. Now, the number that you want to find the unique trait, which I will type in the chat as I say it, is 854 6320. And this number, 85491763320, has some unique traits, and there's one in particular that you can feel free to leave on the Discord if you know what is special about this number, or if you can find out anything else weird about it. So that'll be in the puzzle section on the Discord. To everyone else, whether or not you're on there, thank you all so much for joining me. Good to have you here. We are going to have some exciting things coming that I really want to tell you, but I'm biting my tongue because grade -2 needs some fun surprises at the start of it. So prepare for some fun, interesting stuff coming in that finale, as well as more test answer videos where I will go through some detailed ways you would crack the questions on my final exam and some problem-solving tricks it may help you pick up along the way. And for somebody preferring to figure it out on your own, or is research allowed, if you mean as far as the number in this puzzle, I would say a calculator is allowed. Looking, if you want to look up traits look up how many something or another it has, divide it by something, multiply it by something, look at its factors or whatever. These aren't clues or anything. It's just, if you want to do something like a calculator on it, feel free. If you look up something like what is special about and then type the number, that might end up giving you a spoiler. I'm not sure if you'll find a spoiler from that. So I wouldn't search trying to just hit the answer. But if you need to use tools, you could, So, testing anything on a calculator or whatever. Same with the final exam for people who try those questions. You can, first try your brain, then try rewatching a video, then try looking stuff up if you need, and then finally, look at the answer video or whatever. I'm going to wrap up the stream here. Thank you all so much for joining me, and I will catch you again in that answer video or some other form quite soon. And I have to get busy editing down some crazy footage. Hope you all have a great